All right, I just got back from Walmart. I did a food run. I do a food run once a week, and I did it at the crack of dawn. Whenever I think about doing a food run, I can't sleep late. I can't. So in other words, crack of dawn, I get out of bed and I shoot over there, and I realize as I'm walking over there, the ground is wet. It's rain. I didn't check the weather, so I do it at high speed. It's about a mile. And I got in there, got my food, got back, and it took a little nap. But yesterday, I put the Franklin oscillator back in the test bed, and the Franklin oscillator that I built goes from uh, 1 megacycle to 3 megacycles, right? Something like that. All right, 1.5 to 3. Anyway, I had used this. I see it sparking back there. Anyway, it was it was basically I was making a PTO for the type of circuit which is used in a Drake radio, and then the Collins. I think it was a 51J. It has a PTO that goes between 2 megacycles and 3, and they actually say 3 to 2. They do it backwards. So anyway, that's what that circuit was, and I built it using a toroid coil, and I wanted to see how much drift it has, and it's 100. After it warms up, it's 100 uh, cycles. It goes up and down. Right now, you've seen it. Is it going up or is it going down? It's going up. That's great for a receiver. 100 cycle drift is nothing, especially if you're listening to shortwave AM broadcasts. That's laughable. 100 hertz, you'll never hear it. You'll never even hear that it's drifting. Now, when drift becomes a problem is if you have a dual conversion radio, and then it's more narrow. So then you notice the oscillator's drifting a little bit more, but not listening to an AM broadcast. It's when you listen to the sideband. Code is 100 hertz is not a lot for code. The tone of the beat of the code will be slightly off. It won't bother you. You'll be able to copy the code. In sideband, the guy's voice will start to get more and more sideband, and then as you adjust it, he'll become more and more clear like a human being. And 100 hertz, you will hear the shift. Now, let's get back to this pulling a crystal. Pulling a crystal is ideal for QRP rigs. You're talking the fact that you can go up and down the band, the part you're allowed to transmit on, quite a distance, as far as if someone's next to you, and you can tell the other guy, let's go up. So you go up in frequency, get away from the person. Now, when you pull a crystal, you're not going to drift down into somebody. See, that's what's really good. Older VFOs, as you're on the air, you're drifting a little bit, and you might annoy somebody else as you drift towards them. All right. All the modern units, you don't have to worry about any of this. They also have synthesized oscillators. But what this is for, both the Franklin and the crystal pulling, is the experimenters. Now, there's a really large group of QRP people. There's kits. There's kits for oscillators. And I started checking. I go, okay. So what it is when you get into a hobby, a QRP rig as a kit, you're talking under $50. And now, if you have your license and you know how to do your code, you can now transmit to people within your state on good conditions, locally on regular conditions. And it's the cheapest way into the hobby. And then there's people that just like building things. And you can use, I think it's called Manhattan style, where you cut squares in the circuit board and you make little pads. You can buy the pads. I've done all that. If you go look at my videos, I've done all that type of construction. I use mostly perf board. You know, I'm a big fan of this stuff. You know, they solder on the back. I use pins. I use vector pins. But in other words, I make modules, and in each corner of this board is a hole, so you can mount it. And I have modules, and when I build a module, I don't take it back apart. There's the two crystals in parallel. They're eight megacycles, and I only was able to pull them 3 kilohertz, something like that. All right, so now you follow me this far, you're a person that likes QRP. Now, there's a guy named Doug Demoux. I'm going to give you the link to his book. He did a book on RF. He's like the father, in a way, of QRP. And then there's another guy that shows, it's a YouTube video. I'll post that. He found out how to pull down a crystal. He uses a color burst crystal from a television set. It's 3.579, something like that, which would be in 80 meters, and he can pull it down to 3.5. I have to go over that again for myself. I showed you how to pull a crystal up in frequency by putting a cap in series. Now, when you get really into it, you put not only the variable cap in series with the crystal, you put an inductor in there. That's what I wanted to mention to you. There is another step. And there's a guy that pulled the crystals even further. I'll give you the link to that. And what I'm telling you now is pulling the crystal is for making a transmitter that also receives. I told you with a QRP, you use the same oscillator to both receive and transmit. That's because now you're transmitting on, say, 3.5 megahertz. You're transmitting on 3.5 megahertz. To a guy. You're transmitting just an on and off carrier. He's getting the beat tone at the other end because that's what direct conversions do. They're almost like a regenerative. They actually create the tone at the other end. So you're just turning the oscillator on and off, and he hears you. Now, when he transmits back to you, you switch to receive. When you switch to receive, there's a little capacitor that gets in with your other tuning cap that's on the coil, on the crystal, and it shifts the frequency just a little bit. It's direct conversion. The incoming frequency is 1,000 cycles from the crystal, and instead of producing a 455 IF, it produces a tone, and then you have an audio amp, and that's what direct conversion is. It takes the incoming signal and directly converts it to audio, an audio tone, and without a BFO. So you don't have a BFO, and you don't have to have IFs. You just strictly direct convert it right into an audio tone code. You can also direct convert a person that's in sideband right into audio. It's really cool. You should build at least one. If you have built a regenerative radio, you should build a direct conversion. And it's going to, when you turn it on, it's going to say, this sounds like a regenerative. Yep, it sounds just like a regenerative that's past the regen point. See, with a regenerative, like a kitchen, for AM, you bring it up just before it goes into full oscillations. I'll just call it full oscillation. You bring it up and it starts to howl, and you back it off a little. Now you're copying AM. For code and sideband, you go past the regen point, and that's it. So a kitchen regenerative set does all 3 modes on shortwave. Plus, if you use, in my case, I built this circuit exactly like it should be built. It works incredibly well. It drifts very little. You can copy sideband guys, code guys, AM broadcasts. That's something you should build. All right, and keep the wire short. I've seen videos where the person builds the radio using those solderless breadboard jumpers, and they're a foot long, and they got it coming up out of the board through the air and back down. you don't know what you're doing. I hate to tell you, you don't know what you're doing. When you build a regenerative set, you want wires this short. Right? I can show you my regenerative boards over in the closet there. But in other words, keep it short, and you don't add any inductance. And then lay it out. I have a video that shows you how to lay the parts out, which section, where to put it. It's very similar to the board that Kitchen he had a circuit board out there. I think it was sold by Far Circuits. And if you go order from now, they give you if they still have a circuit board, they give you the one for the Cub Scout one, the regenerative. And nobody's happy with that. Right? That thing is like really a theremin. As you get your hand near the circuit or anywhere, it changes the frequency. But later on, Kitchen come out with that final unit, and it's really good. But the circuit board sold out, and they never made new ones that I know of. I had people contacting me there for a while. I kept in touch, and his second circuit's really good. And then other people started doing their own. What was his name? I did the guy name. I'm half asleep now. I just come up from. I just laid down after that long high-speed run to Walmart through the rain. But I can't think of his name. Oh man. Anyway, the guy that invented the regenerative, they're circuits of his. But the Transistor One Kitchen, he's got the preamp on the front of the radio. He uses an LM389. And now, I mean, in the back of my mind, I'm trying to think of the guy that did the regenerative. I'm not gonna torture myself. I can't remember. I can't remember. When you get older, you just can't remember things. But if you're looking at this video, look in the comments section, and I'll try to put 3 links there. 3 links that will be of interest to you. I know that most people aren't going to build a circuit and pull the oscillator, because on this board here, you can see on the top, that's a 4 megahertz crystal, and then on the back are 2/8, which I jumped this one out. I did the experiment. See, I told you, I build stuff just to see it work. And then I was getting confused how much he was pulling the crystal, because that would have been ideal, because you're talking no drift at all on the crystal. Even though you pulled it off frequency, it's sitting there really stable enough that it's legal to use as a transmitter. I think that's it. All right, that's it for now.